Okay, we're going to be covering sections 3.1 and 3.3 in your textbook. Both sections relate to how you find extreme values for a function, so that's why they kind of go together. Remember that as you go through this video, you should pause it frequently and go back and reread and make sure everything makes sense before you go on. Don't just write down what I say. Pause it and reflect upon it and make sure it makes really good sense to you. Okay, so the first thing is we need a definition of what it means to have extrema. I really think that sometimes when we write out these definitions with a lot of words, we get lost in the words. So I think a picture will actually probably be just as good for us as a long list of words for a definition. So I'm going to sketch a function. This could be any type of function, and I'm just going to draw it like this. Okay? And I'm going to start this function over here at A. That high point right there I'm going to call B. That low point there I'm going to call C. And this point over here I'm going to call D. The word extrema is a word that includes two other words. Extrema means we're either talking about a maximum value or a minimum value. Now, when we have a maximum or a minimum value and we're looking on just a closed interval like this, we're just looking at this function only on the interval from A to D. There are two types of extrema. One is called relative extrema. The other is called absolute. So a relative maximum simply means a place where the function has a maximum within a small interval around that point. So if we look at point B, if I look at a small interval around B, then f of B is a high point, a maximum value. So a relative maximum occurs when x equals B, and the maximum value is f of B. An absolute maximum means on the entire interval, what is the absolute highest point that I see? So if I go all the way from A to D, what is the absolute highest point that I see anywhere on that interval? Well, in this case, it happens to be the same place. So an absolute maximum also occurs at x equals B, and the maximum value is f of B. Okay, for a minimum, we have the same thing. We can have a relative minimum, and we can have an absolute minimum. So a relative minimum is where do I have a low point that is at least low locally. That's another word for relative. So if I look at C, if I look in a small interval around C, C appears to be the location of a low point. So I would say we have a relative minimum at x equals C, and the value there is f of C. But for absolute, I want to know on the entire interval from A to D, what is the absolute lowest point? So if I look on that entire interval, and I want the absolute lowest point, where does it occur? It occurs at x equals A. And that absolute minimum value is f of A. So we have two terms for extrema. We have either relative or absolute. Relative means it is at least locally a high or low point, and absolute means on the interval that you're given, it is the absolute highest or lowest point. Now let's look at where those relative extremes occur. Notice that when I have a relative extreme, a relative maximum or a relative minimum, it's a place where my curve is flattening out. So it appears to be a place where the derivative value would be 0 because I have a horizontal tangent line. Then the absolutes could also occur at that same place. The absolute maximum also occurred at x equals B, but it seems the absolutes could also occur at one of the endpoints if that's where the absolute highest or lowest point is. Okay, based on that picture, we're ready now to actually look at more of a definition. So a couple things. First, there's something called the extreme value theorem. This theorem guarantees that as long as f is continuous on an interval, then f will have to have both a minimum and a maximum on that interval. There's no way to draw something that is continuous and not have it have a maximum and a minimum. Now, you may be thinking, but wait a minute, what if the graph is simply a horizontal line? Does that have a maximum or a minimum? The answer is yes. The maximum value and the minimum value are the same. For example, if this was the line y equals 3, the maximum and the minimum are both 3. So that is possible that you can have that situation. Again, extreme values, when I say what are the extrema, that word values refers to function values. That means the y values. Where maximums and minimums occur refers to the x value, but what is the maximum is asking for the y value. Okay, so where is it that we find extremes? Relative extrema may occur when the derivative is equal to 0 or undefined. So what we're saying here is you could have something that goes up and comes down like that. That would be a relative maximum. But you could also have something that goes up and comes down with a sharp point. That's where the derivative is undefined, but is still a relative maximum. So either of those places could be locations for maximums or minimums. The x values, where the derivative is equal to 0 or undefined, are called the critical values. That's a word you need to know. So the definition of critical value is a place where the derivative is equal to 0 or undefined. And again, those are places where maximums or minimums might occur. Absolute maximums or minimums may also occur at the endpoints of a closed interval. So they can occur either at the ends or at those critical values where the derivative was 0 or undefined. Okay, let's look at an example of how this plays out. Suppose I want you to find the extrema for this function on this interval. Okay, the first thing you should always do if you're asked to find extrema is find the critical values. And again, the critical values are the values of x that make the derivative either 0 or undefined. So first I'm going to take the derivative. Take a moment, pause this, and take the derivative, then start it back up again. All right, here's my derivative, 12x to the third minus 12x squared. I'm going to set that equal to 0 to see where the derivative is equal to 0. If I factor 12x squared out, then I have x minus 1. So my zeros are at 0 and at 1. So 0 and 1 are considered to be critical values. Now we did also say it could be where the derivative is undefined, but because this derivative is a polynomial, it doesn't have any place where it's undefined. That might occur if I had a rational function. Okay, so now I know those are critical values and they may be locations of maximums or minimums, but I don't know which one's a maximum, which one's a minimum. Maybe they're neither one. So the next thing I do is I actually find the function value at the critical values and at the endpoints of the interval. And then I'll be able to compare which one's a max, which one's a min. So I make a table of values with x and f of x. In the table, I'm going to put the endpoints of my interval, which were -1 and 2. So -1 and 2. Now between there, I will put any values that were critical values. In this case, they were 0 and 1. Now, if those had been different, if they had been, say, 1/2 and 1 and 1/2, then those were the values I would have put in here. So these are the critical values, and the -1 and the 2 are the endpoints of the interval. Now I'm going to find the f of x value for each of those. So if I plug -1 into the original function and find the y value, I believe I get 7. Take a moment to pause the video and complete the rest of this table with the y values. All right, you should have found the values that I have listed in the table. 7, 0, -1, 16. Okay, we're asked to find the extrema, which means I want to find the absolute maximum value, and I want to find the absolute minimum value. So just look at the numbers. The absolute highest value is 16. The absolute lowest value is -1. That's it. I just read off the values. So let's go through that one more time. To find where the absolute extremes occur on a closed interval, I start by finding the critical values. That's where the derivative is 0 or does not exist. Then I also find the function value at those critical values and also at the endpoints. So I make this table where I'm finding function values. Then I can just compare the function values and decide what's the absolute highest and what's the absolute lowest. Okay. All right, let's take a look at another example. Okay, find the extrema for this function on this interval. Again, number one, I find the critical values. So to find the critical values, I have to take the derivative. Take a moment, pause the video, and find the derivative of this. Okay, hopefully you got 4 minus 4x to the negative 1/3. Another way to write that is 4 minus 4 over the cube root of x. Now I want to know where this is either equal to 0 or, don't forget, it could also be where f prime of x is undefined. Let's actually talk about that one first. Is there a value of x that would make this derivative here undefined? Sure, x equals 0 would make this undefined because that makes a 0 in the denominator. So that is one of my critical values. Okay, the other critical value occurs if I set this equal to 0. So I'm going to add one of these to the other side. I get 4 equals 4 over the cube root of x. I'm going to cross multiply. 4 cube root of x equals 4. I'll divide. The cube root of x equals 1. And then I'll cube both sides. And I get x equals 1. So my other critical value is x equals 1. Now what I do is I make a table of values with x and f of x. I start by putting the endpoints of the interval, negative 1 and 2, and then I also put in the table any critical values, 0 and 1. Now, don't get misled. When I'm looking at this table, it looks like I'm just counting in order, negative 1, 0, 1, 2. But that's not why I put down 0 and 1. I wasn't just listing every integer from negative 1 to 2. I listed these because they were critical values. If they had not been critical values, I would not have put them in my table. Okay, I'm now going to complete the table with the y values. So I'm plugging these numbers into the original function. Pause the video and put those in and then check and see how you did. Okay, hopefully you got the same values I did. So now I just have to pick out which is the absolute minimum and which is the absolute maximum. So the absolute minimum is the lowest value I see and the absolute maximum is the highest. Absolute minimum in this case would be negative 10 and the absolute maximum would be 0. All right, that's the end of this video. To start the next point, I'm going to go to the next video. So close this one and click on video 2.